Okay, so let's get started. We're going to be taking a look at how to set up and work with advanced nitrous control within our Motec M1 programming. Now, I'm working with a GPRP firmware package for my Motec M150, so the nitrous control is present in my firmware package. Your firmware package might deviate from what we find here in this training module, but the concept of what we're trying to do in terms of this advanced nitrous control programming and tuning will be the same. Let's jump in here and first take a look at where we can find our nitrous control for this advanced tuning. We're going to go in here from our tuning window and jump down here under Motorsports. Now under Motorsports, we have a couple different tabs here to work with. We're going to go into our nitrous specific tab. This is where we can see all the nitrous channels, the configuration, our logging here, and we can keep track of what's going on and how the nitrous is performing. Now, coming up on screen, we're first going to go over the advanced nitrous control layout and understand what's going on in terms of the wiring and the configuration and the schematic. Then we're jumping into our programming language here so we can actually integrate that into the Motec, and we'll find that this particular advanced nitrous control that we're trying to structure here and tune will be dialed in properly. All right, so the first thing we're going to find in our schematic here, we're going to see that we have our Motec M150. Now it has a couple inputs and outputs running to it and coming in and out of it. We'll find that we have a basic arming switch. Now the arming switch is something we've covered in our last training module looking at the basic nitrous control. This is going to tell the Motec that we want to spray nitrous. So in this case, we can see that is going to be a ground input to the Motec. So one leg of the arming switch is going to our battery ground, chassis ground, doesn't really matter. And then the other leg is going into an input pin that we'll designate within our Motec, which is going to be our driver switch 1. Next, we'll find that we have our nitrous bottle, and with the nitrous bottle, we have a heater blanket. The heater blanket makes sure that the bottle pressure will come up to a certain desired range, and that's going to be anywhere between 66 to about 69 bar, or between around 950 to 1000 psi. That's the target bottle pressure. Anything lower than that, our nitrous jet won't flow what it's rated at. Anything more than that, we can start getting excessive pressure built up in the bottle, and we can actually have the bottle explode if the pressure gets too high. So we want to make sure that we're staying in a safe bottle pressure range and the bottle pressure doesn't get too low, so that when we're spraying our nitrous, it's going to do what we'd expect. So if we have a 100 shot of nitrous and our bottle pressure is going to be approximately 950 to 1000 psi or 66 to 69 bar, we'll actually see that amount of nitrous flow coming into the motor. Next, we'll find that we have off the bottle, we're going to have our nitrous line. We're going to have a pressure sensor, and this pressure sensor will be monitoring and measuring our line pressure coming into the nitrous solenoid once the bottle is open. This will be very important because the bottle heater will turn on and off based on that bottle pressure. And we'll also find that the nitrous will only be able to activate above a certain bottle pressure, making sure that we have consistency with our nitrous control. We also have a nitrous solenoid that we'll find, and then off the nitrous solenoid we have our line going to our nitrous jet or jets. So in this particular configuration we have a dry setup, so we're not spraying additional fuel, so we don't have a nitrous jet and a fuel jet. We'll be just spraying the nitrous only, and the additional fuel flow rate will come from our port fuel injectors. In this specific schematic we have just a fogger style nitrous. You may be able to do this in a direct port, doesn't really matter. What we're finding here is the control strategy is really what's important. It doesn't really matter how many nitrous nozzles that we have within the system. Now, in addition to this, we're going to find we have two relays. One relay is a solid state relay. The other relay is a standard 30 amp on-off relay. In the solid state relay, this is Holley part number 15620NOS. This is the solid state relay that I always use for pretty much any standalones if I'm trying to control something in a pulse width modulated format. Now, we're not having the ability to control in this configuration with the bottle pressure sensor and the bottle heater in a pulse width modulated format. That's my ideal way to control nitrous. There is just not enough firmware support within this particular firmware package to support the pulse width modulated style nitrous control. But I like working with the solid state relays because it gives me the flexibility if I want it to go to a pulse width modulated control and maybe not integrate the bottle heater or the bottle pressure sensor. I'm able to do that. So the solid state relay can do just basic on-off control or pulse width modulated. In this particular example, we're going to be doing just on-off control with the solid state relay. And the other relay we find here is just your standardized 30, 40 amp relay. So it's going to have the traditional pins on it, 87, 85, 30, and 86. In this configuration, we'll find that pin 86 and pin 30 are going to get power. Pin 87 is what's going to the bottle heater to turn it on. And then pin 85 is what we ground and a low side ground output from the Motec, which will activate the relay, which activates then the bottle heater, which will then bring the bottle pressure up. And then looking at the Holley relay, we have pins 1, 2, and 3. Pin 3 is our 12 volt in. Pin 1 is our 12 volt out to the nitrous solenoid. Then we have our ground going to chassis grounds or battery ground, doesn't really matter. And then pin 2 is going to be the pulse width modulated, or in this case, the low side triggered on-off style control that is going to activate that solid state relay to essentially pass our voltage from pin 3 to pin 1. And that'll activate the nitrous solenoid under the specific programming conditions. So we can see how everything here is set up and all the wiring is configured.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.